Hi guys, it's Mrs. Rooker again, and I'm going to be doing day 7 with you, which is our last trig day, and it's really, really important because we talk about what the unit circle really gives us and how to use it, and you're going to use the unit circle a ton in trig and in other math classes that you take as well. So really, really, really important things to know is that the unit circle, the ordered pairs in the unit circle, give us cosine and sine. So the x-coordinate of the unit circle is your cosine of theta, and your y-coordinate is your sine. So x equals cosine theta, and y equals sine theta, which is really nice because you'll be able to find cosine and sine just by looking at your unit circle and seeing what your x and your y coordinates are. And then something that we learned earlier is that sine over cosine is tangent. So if you want to find tangent of an angle using your unit circle, you can just do sine over cosine, which is the same as y over x, since y is sine and x is cosine. All right, so we have a completely filled out unit circle. And I kind of talked about this in the last video, but you will have to, at some point, have to fill out your own unit circle. And so it's good to know kind of the patterns for how to fill it out. Again, the reason we call this the unit circle is because the radius is 1. So that means this length from where my pointer is pointing right now to here is 1, meaning this right here is the point 1, 0. But this point here is not going to be 1, 0. You're not going over the full 1 to get to that point. You're going over root 3 over 2 and up a half to get to that point. But the way we find each of these 3 coordinates is a 1, 2, 3, 3, 2, 1 kind of pattern. All of the denominators, you might notice, are 2. So all the denominators are 2. And for the y-coordinate, which remember is sine, you're going to start with 1, then go to root 2, then go to 3. And then for cosine, you just count backward. You're going to start with 3, then go to 2, then 1. And all the numerators have roots on them, except the 1, because if you think about it, if this was root 1 is just 1. So it could have had a root on it, you just don't really need it, it's not necessary. And then everything is just a mirror image of the first quadrant over here in the second quadrant. So this here is a 1/2 comma root 3 over 2, but the 1/2 becomes negative because in the second quadrant your x coordinates are all negative, but your y's are still positive because they're still going upward. Yeah, so that's how you would create your unit circle. So we talk about it a little bit here, this 3, 2, 1 pattern. So for sine, your first one is 1/2. Remember, sine is your y-coordinate. So your y-coordinate is 1/2, then root 2 over 2, then root 3 over 2. So we always start with 1, then 2, then 3 for sine. And we start with 3, then 2, then 1 for cosine. So it's just backward for the both of them. And eventually you'll start to kind of memorize these patterns and memorize how to create your unit circle. You will also memorize your trig values, meaning you'll memorize that, like, I don't know, for example, for pi over 3, if I wanted to know what cosine of pi over 3 is, I could just look. Cosine is your x-coordinate, so cosine of pi over 3 must be 1/2. We can always check that with our calculator. If we type in, let's see what mode I'm in. So I'm in radian mode, which means I can type in cosine of pi over 3 and I should get 1/2 as an answer. So let's see. Cosine of pi over 3 is 0.5, which is 1/2, so it worked. All right. And then this A-Smart Trig class is going to be kind of an important little acronym that helps us to know what our signs are going to be. So what I mean by that is positive versus negative. So The A stands for all. All of your trig functions are going to be positive in quadrant 1. So that means sine is positive, cosine is positive, and tangent is positive. And also the inverse of sine, which is cosecant, the inverse of tangent, which is cotangent, and the inverse of cosine, which is secant. Those will all be positive in quadrant 1. But in quadrant 2, the only ones that are positive are sine and its reciprocal. Did I say inverse before? I meant reciprocal. If I had said inverse, I'm sorry. So really, I don't worry too much about cosecant. I wouldn't focus on that right now. Just focus on our main ones, which are sine, cosine, and tangent. But wherever sine is positive, its reciprocal will also be positive. So the cosecant will be. But the S stands for that sine is the only thing in here that's positive in this quadrant. The only one of sine, cosine, and tangent that is positive in the third quadrant is going to be tangent. So a smart trig class, we know tangent is going to be positive in the third quadrant. And then the C tells us that cosine is positive in the fourth quadrant. So a smart trig class is a way of knowing which functions are positive in specific quadrants. So now we are going to use the unit circle and, our knowledge of the unit circle and a smart trig class to figure out what the value of sine of 3 pi over 4 is without using our calculator. So all you have to do is go to 3 pi over 4 in the unit circle, which is going to be here, and then we go to our y coordinate because sine is your y coordinate, cosine is your x coordinate. So my answer should be root 2 over 2. All right, and if you think about it, that was in quadrant 2. Sine is supposed to be positive in quadrant 2, so it's good that we got a positive answer. All right, so now let's look at cosine of 300. So we'll go back to our unit circle. We'll go to 300 this time. And I believe it was cosine that we're looking at this time. And cosine is your x coordinate. So cosine of 300 is going to be 1/2. Which again, or not again, but we can actually check these all in our calculators. You won't necessarily always have your calculator available to you in Trig, but if we do have our calculators, we can use them. So we want to make sure we're in degree mode this time. So I had already switched over to degree mode, so we're good there. Now we go to cosine of 300, and I got 0.5, which is 1/2, so we're good. All right, next one, secant of 7 pi over 6, which is, again, going to be the same as secant is 1 over cosine. So what I'm going to do is find cosine of 7 pi over 6 and then just do the reciprocal of that. So let's find cosine of 7 pi over 6. We'll go in our unit circle to 7 pi over 6, which is going to be right here in this third quadrant. And we're doing cosine of 7 pi over 6. Cosine is your x coordinate. So that's going to be negative root 3 over 2. But then we have to do the reciprocal of that since we're doing secant. So reciprocal of that is going to be negative 2 over root 3. We don't like our answers to have radicals on the bottom, so we rationalize by multiplying top and bottom by root 3. So we end up getting negative 2 root 3 over 3. Okay, and then the last one in this little example is cosecant, which is 1 over sine of 210. So we're going to go find sine of 210 degrees. So finding 210, oh, it's right here. It's the same place we were before, except we're going to find sine now. Sine is our y coordinate. Sine is y. So this is going to be negative 1/2 But we need to do the reciprocal of that since we're doing cosecant. So the reciprocal of -1/2 is going to be -2/1, which is just -2. All right, so we're really just going to continue with more of the same, but I think what we're going to do now is pretend that we don't have a full unit circle that's been drawn for us. And we're going to think about how we can do this a little more efficiently without looking at the entire unit circle. So what we're going to do is we're just going to draw one part of the unit circle. We're just going to draw quadrant 1. So quadrant 1, this would start with the point, 1, 0. And this is, the angle would be 0 degrees or 0 radians. And then the other, sorry, I'm having a hard time with my writing. So the next one here is going to be 30 degrees, or that's the same as pi over 6. Then we're going to have 45, sorry, I'm kind of shaky, my writing's not so good. 45 degrees, which would be the same as pi over 4. You should have these memorized. And then the next one, horrible writing here, sorry guys, is 60 degrees, which is the same as pi over 3. 60 degrees. And then we should write what the coordinates are. Remember, they're all over 2. So that's really easy, all over 2. So this is what you would do kind of right when you get your test. You'd write out this portion of the unit circle if you didn't already have it in your notes or something. All right, and then the sign or the y values just start with 1, then 2, then 3. But the 2 and 3 need roots on them. And then cosine is the opposite. It's 3 with a root on it, then 2 with a root on it, then 1. All right, and then up here, this would be pi over 2, also known as 90 degrees, and that's going to be the point 0, 1. So all we're going to refer to is this part of the unit circle, and we're going to use kind of our knowledge of a smart trig class and all of that to figure out cosine, sine, cosecant, all that of all these different values. So first we're starting with cosine of 2 pi over 3. So what we're going to look at is pi over 3. So we're going to look here to start, and cosine is your x coordinate, so it's going to be 1/2. So this answer is just going to be 1/2, but then we have to think about if it's positive or if it's going to be negative. If it was in the first quadrant, it would be positive, but 2 pi over 3 isn't in the first quadrant, it's in quadrant 2. So since that's in quadrant 2, we have to look here, a smart trig class. Sine is positive there, but cosine is not. So this will be negative in that quadrant. And we can double check that. We can go to our full unit circle and look here at 2 pi over 3, and it is going to be a -1/2 there. So we're good. All right, sine of 11 pi over 6. So what I'm going to do is look at just normal pi over 6, not 11 pi over 6. So that's here. And sine is going to be 1/2. But we're not in the first quadrant since this is 11 pi over 6. We are actually in the fourth quadrant. So a smart trig class. In the fourth quadrant, cosine would be positive but not sine. So sine would be negative for that one. All right, moving on. Feel free to pause the video if I'm going too fast. All right, cosecant of 5 pi over 4. We are first going to find sine of 5 pi over 4, and then just do the reciprocal of that to get cosecant, since cosecant is the reciprocal of sine. So we're just going to look on our unit circle at regular pi over 4, and both x and y coordinates are √2/2 there. So we know it's going to be a √2/2. And now we need to figure out if it's going to be positive or negative. Since 5 pi over 4 is in the third quadrant, 5 pi over 4 is in the third quadrant, which if you don't know, you can basically think about the fact that anything in the second quadrant is going to be slightly less than pi. Anything in the third quadrant is going to be slightly more than pi because it's just past pi. So that's going to be in the third quadrant. A smart trig class, sign is going to be negative in that quadrant. So this will be negative, but remember we need to do the reciprocal of that. So this is going to be negative 2 over root 2. To get rid of the root, we multiply top and bottom by root 2. We end up getting negative 2 root 2 over 2. The 2's cancel. We should just get negative root 2 as our answer. Kind of ran out of room for number 8, so we'll have to change colors and squeeze it in there. So sine of 5 pi over 3. So we're going to find just sine of pi over 3. So we look at pi over 3 right here, and sine is your y coordinate. So it's just going to be root 3 over 2. But then we need to check if it's going to be positive or negative. 5 pi over 3 is in the fourth quadrant because it is almost 6 pi over 3, which would reduce to 2 pi, which would put us at 1 full revolution. So that's fourth quadrant. Oops, fourth quadrant. And a smart trig class, sine is going to be negative in that fourth quadrant. So that's our answer for number 8. If you guys want to, go ahead and pause the video and try the next few on your own. See if you can figure them out without looking at the full unit circle, just looking at the first quadrant of the unit circle. All right, number 9, we have cosine of negative pi over 4. So we're just going to find cosine of regular plain old pi over 4, and so that's going to be here pi over 4. Cosine is your x coordinate, so it's going to be root 3 over 2. But then think a smart trig class. Oh, sorry, I should have said negative pi over 4 is just going to be going the other way around the circle. Instead of going counterclockwise, we're going clockwise. So that's going to put us in quadrant 4. A smart trig class, cosine is positive in quadrant 4. Not that you need to write that little positive symbol, but it's a good reminder to know that it's positive since it's actually the first positive answer we've gotten. All right, the next one, cosine of 13 pi over 6. You won't see 13 pi over 6 on the unit circle because that is more than 2 pi. That is more than 1 full revolution. So 12 pi over 6 would be 1 full revolution, and then that's 1 more pi over 6 past that. So that basically just puts us all the way around the unit circle, and then 1 more pi over 6. It's going to terminate right here at pi over 6. Which means I just need to know what cosine of pi over 6 is, and I'm good. So cosine of pi over 6 is this coordinate here, and it's your x coordinate, which is root 3 over 2. And it's positive since it's in the first quadrant. 2 pi over 3, I'm going to do 1 over cosine of 2 pi over 3, since secant is just the reciprocal of cosine. So cosine of just plain old pi over 3 is going to be 1/2. But then we need to think about the fact that this is actually in the second quadrant. Second quadrant, a smart trig class, cosine is going to be negative in that quadrant. So it's negative 1/2. But since we're doing secant, not cosine, we need to do the reciprocal of that. So the reciprocal of 1/2 is just going to be 2. So my answer should be negative 2. Okay, last one right here, sine of negative pi over 6. So we know negative pi over 6 is going to be going down or clockwise, not counterclockwise. So it's going to put us in the fourth quadrant. And pi over 6 is right here. I just look at sine as your y coordinate, so it's going to be 1/2. Oops, why did I put it on the fourth? Oh, I was thinking about the fourth quadrant. So it's 1/2, but since it's in the fourth quadrant, a smart trig class, sine is negative in that quadrant. Because remember, these are the only ones that are positive in these quadrants. So sine must be negative. All right, so now we're going to deal with tangent and the fact that tangent is sine over cosine. So for these, just kind of in order to save time, I'm going to go to my actual full unit circle so that we don't have to worry about trying to figure out which quadrant we're in and all of that fun stuff. But remember, tangent is sine over cosine, which is the same as y over x on our unit circle, since sine is y and cosine is x on the unit circle. So for tangent 135, we'll go all the way to our, I think that was 315. For tangent of 315, we're going to go to 315 in the unit circle. And tangent is going to be y over x, or sine over cosine. Well, since sine and cosine are the same numbers, whenever you divide something by itself, you just get 1. So root 2 over 2 divided by root 2 over 2 is just going to be 1. But the fact that there's a negative here means our answer is going to be negative 1, which hopefully makes sense because tangent should be negative in that fourth quadrant. All right, now we'll do cotangent of 5 pi over 4. So we're going to find tangent of 5 pi over 4, and then just do the reciprocal of that, since cotangent is the reciprocal of tangent. So we'll go up to 5 pi over 4, which should be in our fourth quadrant right here. Well, again, we end up with root 2 over 2 divided by root 2 over 2, which is nice because you're just dividing something by itself. And a negative divided by a negative will be a positive, so this will be positive 1. And then the reciprocal of 1 is still just 1. So our answer for that one is just positive 1. Right. This is something you will eventually memorize, that anytime you have a reference angle of pi over 4, your tangent is just going to be 1. That's something you'll memorize. Tangent of pi over 4 is 1. All right, tangent of pi over 3 is not going to be 1, so we'll have to do a little more math on these. So we're going to go to 2 pi over 3. 2 pi over 3 is right here. And remember, tangent is sine over cosine, so it's going to end up being root 3 over 2 over negative 1/2. So let's do that. Root 3 over 2 over negative 1/2. A couple different ways to think about this, but I guess the best way is probably to just write this out as root 3 over 2 times, since this is division, it's like multiplying by the reciprocal, so times negative 2 over 1, and the 2's will cancel. So we'll end up getting negative root 3 over 1. You don't even need the over 1. So our answer is just negative root 3. Another way of thinking about this is if your denominators on both fractions are the same, they can cancel. So, sorry, my thing froze up on me. There we go. The denominators were the same, so they just canceled. So we got root 3 over negative 1. Again, another thing that you'll memorize, anytime you have a pi over 3 reference angle for tangent, it's just going to be a root 3 answer. All right, last one in this section. 7 pi over 6, tangent of 7 pi over 6. 7 pi over 6 should be in our third quadrant right here. Tangent is y over x, so negative 1/2 divided by negative root 3 over 2. The negatives will cancel, so we'll just do 1/2 over root 3 over 2. 1/2 over root 3 over 2. Well, the 2's are going to cancel. The denominators are the same, they'll cancel. We'll be left with 1 over root 3. You cannot leave your answer like that, so we need to rationalize by multiplying top and bottom by root 3. And we end up getting root 3 over 3. And if you think about it, that was in the third quadrant. A smart trig class tangent should be positive in that third quadrant. So we're good. All right, we're almost done. One more little section and then we are done with this unit. Now what we're doing is finding all the possible values in degrees and radians for the missing angle in each equation, which basically means we're solving for what theta could be. And theta could have a couple different answers. And I should kind of specify that we're just talking about within one revolution, so from 0 to 2 pi, because technically this could have an infinite amount of answers, but we're only focused on between 0 and 2 pi, or 0 and 360, since they want degrees and radians. So we need to think about all of the places on the unit circle where sine could be 1/2. First thing I like to think about is the fact that this is positive. So we would need to think about which quadrants will have sine be positive. So A stands for all. So sine is positive in the first quadrant, since all of them are positive in the first quadrant. Then S here stands for sine. So sine is positive in the second quadrant. TC means it's tangent's positive there in T. Cosine's positive there, so sine is not positive in those quadrants. So our answers are only going to be in quadrants 1 and 2. All right, if we look at our unit circle, we've got it right here. Sine is our y coordinate. So sine is 1/2 here, at pi over 6, and also here at 5 pi over 6. And those should be our only two answers, because sine is going to be negative in all other quadrants. So my answer is going to be pi over 6 and 5 pi over 6. Also 30 and 150, since we're supposed to do these in degrees and radians. So 30 and 150, 30 degrees, 150 degrees, pi over 6, and 5 pi over 6 are all the possible places in degrees and radians that sine is going to equal 1/2. All right, throwing a little more challenging one at you. Where is tangent going to be negative √3? Well, we saw in these last problems up here that tangent was √3 at pi over 3. So we know this is going to be a pi over 3. But it's got to be negative, so we need to find which quadrant's tangent is going to be negative. It's not negative in that first quadrant, because they're all positive there. It's also not negative here, because tangent's positive there. So it's going to be in the second quadrant and the fourth quadrant that's going to give us a negative value for tangent. So it's not called pi over 3 when it's in the second quadrant. It's called 2 pi over 3. And 3 pi over 3 would reduce. 4 pi over 3 would be in the third quadrant. So 5 pi over 3 is what's in the fourth quadrant. So those are our answers in radians. And then you may have those memorized converting to radians, or we could just look at our unit circle at 2 pi over 3 and 5 pi over 3. So 2 pi over 3 is the same as 120. And then 5 pi over 3 is 300. So 120 and 300 are going to be our answers in degrees. And remember to put the degree symbol on degrees, otherwise it'll look like you're talking about radians. Is cosine going to be positive √2 over 2? So we know cosine is positive here because they're all positive here in quadrant 1. Cosine is also positive here in quadrant 4. It's going to be quadrant 1 and quadrant 4. And we know that cosine is √2 over 2. If we look at just our positive part of the unit circle, cosine is √2 over 2 at pi over 4. So one of my answers is going to be pi over 4. My other one is going to be that same reference angle, but in the fourth quadrant. So think about it. 8 pi over 4 would reduce to pi over 2, or sorry, 2 pi, which would be one full revolution. So if we want to be in quadrant 4, we want to be just short of that, so that's going to be 7 pi over 4. And we can check in our unit circle and see if that is the correct one for quadrant 4. So we've got pi over 4 and 7 pi over 4 that we're looking for in our unit circle. Sorry if you're getting dizzy going back and forth to the unit circle. So here's pi over 4, and cosine is positive √2 over 2. Perfect. And then here's 7 pi over 4 in the fourth quadrant, and cosine is positive √2 over 2. So we're good. Oh, we should also put what those are in degrees. So that's 45 degrees and 315 degrees. All right, couple more. If you want to pause the video and try these, you're welcome to. These are a little bit trickier. Cosecant is of theta is -2, which would mean that sine of theta would be -1/2, because sine is the reciprocal. I would much rather deal with sine than cosecant, so I'm going to immediately change that into a sine. And then we want to think about where sine is positive. Smart, trig, class. Actually, we want to think about where sine is a negative. Sine is going to be negative here and here. So that's going to be quadrants 3 and 4. And sine is going to be 1/2